Hello, this video is going to walk through how to make a model in Mesa. It's an agent-based modeling platform in Python, and I'm using it in my course on scientific computing to explain a number of agent-based models for analyzing system dynamics. So the one that I'm going to be creating is about diffusion. This is our first model we'll walk through. And so diffusion of chemicals, we want to be able to drop some chemicals in the world and have them diffuse out and then slowly fade away and disappear. Okay, so let's see how we would do that. In terms of making the model itself, the first thing we need to do is do pip install Mesa. Now for me, this has already been installed, so my requirements are all set. And this is the created model. I'm going to show you what you would do once you do have a model. You would be able to go into that directory and say Mesa run server, and the model will run in your browser. And the way that I've created this model to start off, I have an evaporation rate. How much do I want that chemical to evaporate? A diffusion rate. How much do I want it to spread into other cells? And then what is the amount of the initial drop of that chemical in the environment? Mesa also has a speed slider up here that you can pick how fast you want your simulation to be running. And it lets you create these sliders. And here is your two-dimensional grid of agents. My agents are living in there. Every single cell is an agent, and the agents are colored depending on the amount of chemical that is in them. So let's go ahead and start the model. And the model starts with a number of cells randomly having chemical, and then as it runs, the chemical is diffused and evaporated away from the environment, and it should be able to start disappearing after a little bit. You can see that it is fading as the time goes by. It is fading into lighter and lighter pink, and the chemical should disappear after a certain amount of time has gone by. Okay, so let's start writing this model. I'm going to start writing it from scratch here. So I have a folder, Diffusion Mesa. I am going to create a folder in here to keep track of my Python files. Let's call it Diffusion. Okay, the first thing we want in there is the agents file. And I'm going to make a new file, agents.py. And from Mesa, I'm going to import the agent class. This is going to be something that comes from the Mesa package. Things that I want to create in my model are agents. So how does that happen? We're going to make a class for the environment and base it off of the agent class. Okay, so I'm starting off making my own agent. Here is my init method, my constructor, self. I need a position, and I need to talk to the model. Now the model we haven't defined yet, but I am saying there is a model out there that's going to be holding a lot of cool things. We'll get to those as we start writing about them, but one thing it's going to be holding is the values for global parameters, things that every agent is going to need to know about. Some of those values for the sliders, they're going to exist in the model. The model is also going to be able to have a grid, so it knows where we are, and it can talk to our neighbors, and it is the thing that keeps track of time. So we will build the model next, but I do want to build an agent first that says, I am going to call things that are related to agent up here, give it my position, and give it the model. This is sort of a requirement. If you are making an agent, you need to set up the super agent. And then you get to do stuff that is specific to you. So I'm going to save my position here. and I'm going to create an amount, which is the amount of chemical that I currently have. Now, this position here is sort of hiding something in the background. An agent needs a unique identifier. Now, right now, these agents are going to be in our world at certain XY coordinates. And those XY coordinates are going to be the unique identifier. There's not going to be any other agents in there. So for this model, we can be simple and just say that this agent's ID is its position. We might have to get more complicated for the next models we make, but for right now, that will work. Okay, the other thing that agents need to do is step. Someone is going to say, hey agent, it's your turn to do things. That is the step function. And the step function, remember, says now I need to change myself and get ready for the next time step. We are actually going to define two things because our agents here all need to work simultaneously. So it is going to have two things inside it, a step and advance. So I'll just put those in there right now. Other things that we want to be able to have our agent do to be helpful for us is going to be able to add an amount, and we want to get the position. Oh, I want to write all these later. So this is going to be the structure of what my agent needs to do. What am I going to do next time? Get ready for it. Advance. Everybody simultaneously makes their decision about what to do for next time. Sometimes I might need to add some amount of chemical, and then I am going to be able to get the position back of where it is. Okay, so let's figure out the step. In order to step, an agent says, I have an amount. I need to spread that to my neighbors. Okay, so let's calculate to do this all of the chemical that I have and my neighbors have. The first thing I want to sort of figure out is all the pheromone, all of the chemical that is around. So I'm going to have mine, and then let's go talk to my neighbors. My neighbors are going to be inside the model. The model has the grid, and the grid has this really nice method called getNeighbors. If I give it my position, I can get my neighbors, and I want to get all 8 neighbors. And so I'm going to say true here. Okay, so for each neighbor, add up their amounts. I know that every single neighbor in my model is going to be another environment agent, and they're going to have an amount. And so now I have all the amounts put together. What is the average amount among myself and my 8 neighbors all put together? It's going to be adding it all together divided by the length of neighbors plus 1. So this is going to say I have all of my neighbors put together, divide it out, and I have the average amount of pheromone everywhere. Okay, so now what is my next amount going to be? A couple of things I need to figure out. I need to figure out how far away I am from my average amount of everybody else. If I have more, then I need to be spreading it to my neighbors. If I have less, then my neighbors are going to be spreading it to me. So what's the difference between that average amount and my amount? If my amount is more, then this is a negative number. I have stuff to get rid of. So that would be simple. I would just be able to say, let's spread it all out. But I need to account for the diffusion parameter. If my diffusion parameter is 1, then yes, I give all away and I get everything from my neighbors. If it's 0, then I don't give anything away. And so I need to multiply this model.diffusion, that parameter I was talking about. I am going to be putting that together. So this is now the amount that I am going to be spreading to my neighbors or keeping to myself based on that average. Okay, but another thing has to happen. We have to evaporate. So I can't just do that. I have to do a little bit more here. And I have to do 1 minus self.model evaporate, but then I'm going to multiply it times this self.amount plus what I have here. I want to multiply it there and multiply it there. Okay, so let's talk through that formula again. What should I be next time? I should be self.amount plus the difference that I have between myself and the average amount everywhere. Multiply that times the diffusion parameter for how much should be really spread out, and then multiply that times the evaporation parameter. And so evaporate is really small, then it's 1 minus that is kept around. And if the evaporate is really big, then a lot of it should be disappearing, and so this is going to be a very small number that gets multiplied. Okay, so I get that ready, and then one more thing I need to say, well, if self.next amount is less than a lower bound, then self.next amount is equal to 0. Now this just helps things actually evaporate and helps things disappear when numbers get too small. Otherwise we're doing tons and tons of calculations when we don't need to because the numbers are so small we can't see them on the screen. Okay, so how do I advance? Self.amount is equal to self.next amount. This is my private amount that I calculated up here. Everybody goes through this step, and because we all go through it without changing self.amount, then these calculations, everybody's going to be able to go to their neighbors and know that this amount is consistent among everybody's step. Then we all advance, and then we've got a few more things down here. I might want to say self.amount plus equals the amount coming in. Someone says, hey, I'm dropping some more chemical right here. And the last thing, return self.position. Okay, so this is my agent. The environment, there's a lot of things that come from Mesa. The grid, the super up here, other pieces of what's going on, making sure I name things the right pieces of step and advance. And then we should be all set to have an agent. Okay, next video, we will build the model.